Students, welcome to today's class. We shall be discussing on the ignition system. The ignition system. We have two types of ignition system. We have coil or convectional ignition system. Number two, we have electric ignition system. Now, today we shall discuss on coil or convectional ignition system. As you can see, the components involved are the battery, the ignition switch, we have the low tension cable, the primary windings, the iron core, the secondary windings, high tension cables, and we have the distributor. Then we have the contact breaker and the capacitor. The function of the capacitor is just to store charges for a moment. So we have also the spark plugs used to produce sparks to the required cylinder. Now let us look at the operation of the system. You know there is a difference when the engine is on, and when we start the engine and cranking. When you put the engine on, actually all the electrical components, they are functional. You can either put on the hazard light, the radio, you can tune the radio on when the engine is on. But once you start the engine, the engine will start running. Cranking is the process of starting the engine. Cranking is the process of starting the engine. As you see, when you put the engine in, when you want it to start, there is this voice that comes from the engine. This is cranking. The engine is trying to peak. You are trying to crank to start the engine. Now, let us see what happens when the engine is on. Once you put the engine on, the current flows from the battery through the ignition switch or the ignition key and the low tension cables to the primary winding, creating a magnetic field. We are saying when you put the engine on, the current will flow from the battery through the low tension cables to the primary winding, creating a magnetic field. When you start the engine, when the engine is starting, the contact breaker opens. The contact breaker opens, stopping the current flowing to the primary winding. Once the contact breaker opens, it switches off the current which was flowing to the primary winding. There being no current flowing to the primary winding, the magnetic field was created here, collapses, producing a very high voltage required for the spark plug. We are saying when the engine is starting, the contact breaker is open and stopping the current flowing to the primary winding. There being no current flowing to the primary winding, the magnetic field collapses, producing a very high voltage required for the spark plug. Then the high voltage is taken to the distributor through the high tension cable, and as the rotor rotates, it distributes the high voltage to the spark plugs through the segment, or it distributes the high voltage to the spark plug, which are responsible to produce sparks. Remember, the battery is only 12 voltage. Now, this solenoid or this primary winding and this solenoid is able to multiply the 12 volt times 10 to power 3. This is equivalent to 12,000 voltage. This is a very high voltage that is coming from the secondary winding. So these are the voltage required to produce sparks to the spark plugs. Thank you. We shall continue from there.